Alright, this is a video by Cosmos News, and it's about Comet 67P, and they're talking about all the features on it and how they're very bizarre and hard to understand, and they are unless you understand that this is a product of life. You see this thing? That one, bang, 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 bang. They go all the way around. You know what those are? Those are tendon emplacement plagioclases. I guarantee you, if you test what this is made out of, it's made out of this spiky plagioclase material, and it does not erode. That's why it hasn't eroded. All of the biological organic matter that is fleshy is eroding. It turns into it actually turns into feldspar as the cells become petrified, literally petrified, and they turn into feldspar particles based on where they were close to, what kind of chemicals they were in the mix of, and some of them have a lot more blood in them than other ones and so forth. But this is entirely a product of life, and this is a tendon emplacement. I tend to show exact evidence to prove this, and in addition to this, that the asteroids that are coming in are also products of life, and I have evidence to support that as well. I'll show you that right now. Alright, you saw all the step overs in the other tendon, and this, I mean in the piece of muscle that I showed you, and these are exactly these spiky little overlaying tendinous flaps. They're made out of collagens and keragens in humans, and I'm sure these are the same things. And these little erosion things here, those are blood and some of the minerals that are in this particular structure, and I'm going to show you that structure right now. Alright, this is from astro.washington.edu. Doesn't get any clearer than this. The vein and the artery. I mean, the vein, it's one or the other, whatever. One of them clamps off and one of them doesn't. I got the same things here. I got copious amounts of them. And one of them is red and one of them is black. And the black one is the one that clamps off, so it must be the vein. And the other one is the open one. And I have exactly the same structures here. And here it is right here. You see that? That's the black one. And that's the red one. There's absolutely zero difference. Zero, except this didn't come through re-entry and burn up and turn into metal, because metal will smelt this, because guess what? This is literally loaded with blood. I mean, it's soaked with blood. This was actually bled, literally bled when I cracked this open. These are tendinensis points. And when they're in a lung, forget about it. The lung is 100% iron, and the iron just smelts when it comes through the atmosphere. Alright, this is from dev.biologist.com, or .org, I'm sorry. And this is the way tendons grow. This is all that blood red stuff is coming in here when you start to develop. And then it changes a little bit. You start to get some differentiation, and you start to get some minerals collecting. Now this is just as you're developing as an infant. Until these things start to embed themselves. Then you get more and more minerals, but you still got that red, gooey, bloody stuff. These, you see how they're originally, now they start to make themselves into like little vascular tubes. And I will show you exactly what they are. Those are triangular, they're little plates, just exactly what they're showing here. And then this goes here, and then that happens, and then they get worse and worse and worse. Oh, well, not worse, but they get this round structure that I showed you, exact same thing, with the stalk coming out of it, with this tube coming away from it that has those vascular entries that burnt up. Now, there's all your red gooey stuff that was all over that I showed you. Now, that's just what it is. Now I'm going to show you what these are, and I'm going to show you the rocks that they're coming out of, and they are very, very ancient. Alright, and I show this. This is a tendon ball, identical structure that's on Comet 67P, or that is Comet 67P. If you look at all of the different structures that are on this, the two different types of tendon heads that are sticking out, there would be muscle straps attached to there, and they break off where it transitions. I have a full video of it showing the transition points. I have all the chemistry, I have the anatomists, I have the DNA tests and the CAT scans, and it's proven what it is. Now that's what the spiky little plagioclases that in a tendon ball look like. And that tendon ball is invested up this way, and that stuff has eroded away. But if that was upside down, and they come up this way, and they, you know, this could be upside down, it doesn't matter. It more than likely was in the other direction, and this eroded downwards. But at any rate, you could see the structure would give you those cave entrances if it hadn't washed away like that. Alright, this is where the muscle was, and these are the muscle fibers all broke off, and I showed how they wave in the other part. This is a better place to show you, because this is where it transitions from the muscle into this gooey no man's land, and then into the fibrous tendons that run into bundles and go down further, and would run down this way into that big ball with the claws on it. Alright, this is a specimen that I have that has these features in it. Now, if you see all these little stripy things, those are the things that were coming out of the tendon ball. And this one is broken here. From here, these were where the tendons would have invested into the ball, which would have been on this end, but it's broken. And this would be where the neck was. Now, I'm going to follow this down. I'm going to play the video that I made on this. So just listen to this now. I'm going to play it, and it's going to, what I'm going to do, just so you understand what's going to happen here, I'm going to pan the camera down this way, and you're going to see how this transitions from this tendinous fibrous material into a bloody substance which mats this up to the muscle, yeah, to the muscle. All right, just hold on a second and you'll see this. Away from it, or I'm going to twist around from it, because this is amazing what happens. Now, as I move up the fibers, all of a sudden, see them, they're like little, they look like boards, you know, and then all of a sudden, bang, look at that. Look at that. Now, this white stuff, you see that? That's mineral. These things are extremely mineralized. And they make these little patterns, you know, they're almost like little crop circles and things. But anyway, as you go up further, up the tendon, you get this material. Let me see if I can focus this in a little better. Alright, you see this material here? You see everything's striated, and there's I have to block the light coming in from the side. Now, you see this reddish stuff? That's all starting to, there's some kind of blood investment here. And this is a transition, and my stuff breaks at a certain spot, and every one of them, I always wondered why. And I see this exact same structure in the Giant's Causeway and a lot of places, and I'll show you that later. Now, you see these things? This is vascular stuff. That's blood. That's where the blood is servicing these things. Now, I'm going to go a little further up, and you're going to see what happens now. It says, okay, what are we going to do from the tendons? We have to make a transition into the muscle. And here comes the muscle. Isn't that something? And so you're going to have another sort of, and here comes the muscle fiber. The black and the white, or, you know, it's brown and white or whatever color it is, but that's muscle fiber. Now, I'm going to home in on this a little better if I can. Now, you still see minerals in there and things, but it takes on this band of fibers, and they weave into each other, and they still get service with blood here and there, and then it goes off that way, and it broke off on this end too. But this is the identical, you see these things here? This is the identical structure you see on Mars, you see everywhere. And these are the blood service holes, and what that is iron. And iron rusts out of here, and that's why it's the red planet. And it's what it is what it is. I didn't make it up, it's just what it is. Alright, this is one of the fossils that I have, a mud fossil. And this is how the veins go, because they clamp off and they can't release their bodily fluids. And that's how the arteries purge, because they blow out. This is the fascia, connective tissue that surrounds everything. Some more of it here. Up in here, this is blood. This was a bloody rich blood layer. And that, if I soak that, that'll rehydrate and turn red, just like blood again. And there's plagioclases. Here's some more of the red bloodish stuff in there. Now, this is plagioclase. You see that? That spiky stuff? That is what happens in tendons. This is another tendon emplacement. And it's still wrapped with most of the fleshy material. The other ones are degraded more. But that's what happens, and they come out in layers. A layer comes out, and it has a little tag on it that wraps around here, and in the center is that ball that goes down inside, that big ball that we see. And then below it, there's be another, here's another layer here. After this tendon there's another layer here, and then there's another tendon ball underneath in here. And they're all over the place. And that's how you anchor these tendons. And these creatures were gigantic, and they had some serious tendon anchors, because these are microscopic. In a human being, you can almost hardly make that out. So that's what it is, and that's just what it is. And that Comet has them. All right, actually I'll show you that this is the plagioclase material, and this is the stuff that I am saying is on those spiky little teeth coming out of these tendon emplacements. And I'm, it's fully understood that they are mineralized tendon emplacements, and the architecture of them is identical to human anatomy and other creatures' anatomy, and it appears that the entire universe is alive. That's all I can say. And this is the product, and I guarantee you that that's what's going to be inside of these items that are the balls that are falling down around the neck, and they are also those bumps that are sticking out that I just showed a minute ago. And later I will show the asteroids and the vascular articulation of iron asteroids, because when they come through the out surface of the earth, they literally get smelted into iron, because iron is blood. And the ones that hit the earth, and I have some exquisite specimens to show, literally are normally lungs. All right, this is a lung as well, and of course, like I said, it was in a volcanic area, but inside the lung, you see that? It still has different chemicals that were that didn't, bleach out of here deep inside, and they're finding these inside of dinosaurs and all this stuff. And if you look at this closely in a microscope, it's obvious what it is. It's blood. Now, inside of that, you're going to have the same thing. You go deep into that, you're going to have the same thing. You're going to find blood or some remnant of organic tissue that didn't get able to escape. I guarantee it. It's going to be there. That thing was skinned over, just like my mud fossils get skinned over. They get electroplated in the ground, and the stuff that's encapsulated inside stays. It cannot escape. And there is some in there, guaranteed. All right, here we go again. A palisite. Same sort of stuff. This is the vascular cellular network of lungs. It's just the way it is. And they turn into iron because they're literally smelted due to the heat of re-entry.